Hello and welcome to part 1 of our tutorial on Unity. First thing we need to do is, with the Unity Hub open, is start a new project. And so if we come over here to New Project, click on the button, we can choose the template that we're going to use. For our game, we're just going to do the very top one here, this very simple one, 2D. And over here, we can give the project a name, whatever you like to call it. Maybe my game. You could be more descriptive. And then we make sure that we save it somewhere. So I'm going to save it on my desktop, and you can do the same. It doesn't work very well on the school's servers, so just make sure that you click onto the desktop. If it doesn't work here, you can always go under this PC, desktop, and then create a folder. And you can call it the same name if you want. And just make sure that that folder is selected. So select that folder, and once you've got those two things done, you create the project. Now it's going to build a bunch of files and do a bunch of things. It's going to take a minute or two. Just be patient. And after a few minutes, you'll be confronted with this screen here. So we'll talk about this. If this does pop up, Unity Editor Update Check, just skip the new version. You can turn that off so you're not bothered by it. We'll just be using the version that's installed on the computer. Don't download the new version. So I'll just click that, skip new version. Now just to give you a little bit of an overview here, this is the standard window format. What you're looking at here is a hierarchy window on the far left side. This will be whatever's in your scene, and your scene is sort of the game that you're working on currently, sort of the level you're working on. You can think of it as that. And at this time, in our sample scene, we only have one thing, and that is the camera. We'll put new things in there pretty soon. In this window here, it's your scene window. You can kind of think about it as your working window. You can drag things in, move things around. So we'll be adding things to this window in a minute. There is a tab here that shows what the game looks like. And because we have nothing in our game, but we do have the game camera, this is what our game looks like. Just a black, sort of a blue background here. What else is there? Down on the bottom half of the screen, there's two important things here, the project and the console. The project tab has all the assets, all the stuff that we'll be working with here. So down in here, we'll be putting in our scenes here, but we'll be putting in our scripts, our sprites, sounds, everything that's sort of going to go into our game. We can put in here, and it works on the same sort of file structure and folder structure that you would find like on your computer, sort of in a Windows computer. You'd find those files and folders. You can organize the same way, and we'll do that down here as well. There's also the console here, which doesn't show anything at the moment, but if we have any error messages or we're trying to figure out what's going on, that's where this is going to come easy. So it's good for debugging, and we're able to sort of use that. And again, we'll see this a little bit later. On the far right side, so there's an inspector. I have the camera selected at the moment, and so there are sort of the components that make up each of the game objects. So these will be game objects here on the hierarchy window, and each of those game objects will contain certain components. All of them will have a transform, and that's their location in 3D space in our game here. So you can see our camera has an X position, a Y position, and a negative or a Z position of -10, so 0, 0, -10. That's just to move the camera back a little bit, no rotation, and the scale is set to 1. And then we have another component, which is the camera component. And if I turn that off, it's no longer a camera. It's interesting, it still shows this here. Whenever I go to game, so game, it will show no cameras rendering because we've turned that off. Turn it back on, the camera is working. So this component here makes it into a camera. This is a built-in component, and you can see down here, there's add components. We'll look at those later. But this is a camera component that you could add to your game object, so it becomes a camera. As you can see, there's lots and lots of settings. Our purpose here is not to learn every single one, but just to understand that there's lots of things you can do to change things up. Now we're going to do a few little housekeeping things just to make sure that everything goes smoothly as we progress here. So let's first just come down to the project window again, so make sure that that's open. Let's create a few folders here. This is, like I said, just sort of housekeeping at the moment. We're going to create a couple folders. So I'm just going to, right click, create, and there's folder. And in there, we'll call one sprites. So I'm going to, and let me sort of zoom in on that a little bit, make it a little bit, it's not much more visible, but that's a sprites folder. It's showing up as empty. We haven't put any sprites in there. We'll create a new one as well. So again, right click is the easiest way, create a folder, and we'll call this one scripts. So the code that we're going to write is called a script. We'll create another one, folder. We might as well put in our prefabs, which we will use later on again. Don't worry too much about this, but it is something that's going to be useful to when we create an object, if we want to use it again and again, we can make it a prefab. We'll make one more folder. This is sort of a aspirational folder, so hopefully you'll be able to use it and add some sounds to your game to make it better. So these folders here, as you can see, they're all in this assets folder. And if you actually went into Unity, like the game that you're making, you'd actually be able to drill down and find your assets, and all these folders would be in there. So they're sort of accessible outside of Unity as well. But if you're adding anything, I highly suggest that you sort of work within this file structure here. Okay, don't try to modify it outside of the game itself here. So once we got that done, let us go up and set a few little things for our project here. Now, I'm going to go down to Preferences, so right here, so in the Edit menu, Preferences, and what we'll come down to, yours probably won't show up exactly here, but come down to External Tools, click on it, and what we want to make sure is that the external script editor is set to Visual Studio. And so on these computers, they should have Microsoft Visual Studio 2022. Click on that. That will make sure that when we open up Visual Studio, the proper sort of help is available to us. It knows what it's doing. It's doing sort of Unity stuff. Okay, so that should be pretty good there. Now I'm going to give one other little tip here that I've learned over the years, and that is with the colors. And just before I do that, I'll just sort of explain a little bit here. When you hit play, okay, hit play here, we're in play mode. And the only indication that you're in play mode is this little blue button up here, right? It's sort of changed from the gray to this blue. Otherwise, you really can't tell that you're in play mode because you can click on here, you can modify and change things, and you're busy in play mode. And the trouble is that when you do that, if you make changes, most of those changes, once you unclick play, will disappear. And so a lot of times students and myself and professional Unity users, we forget that we're in play mode, change some things, and then get a little bit frustrated. So what we can do to sort of help us out here is click on colors, and down in, sort of well, it's not alphabetical here, but there is one about halfway down that says play mode tint. And at the moment it's sort of nothing. You can give it a bit of a color. So you choose the color you like. Okay, I'm just going to go for a bit of a red on it. I try not to go too strong on the color because then it can make legibility a little, it's hard to sort of read what's going on there. But if I do that, hit play, what you'll notice is that now I have a red sort of, tint to everything except the game window. But it's sort of a visual indicator for me that, hey, you are in play mode. So any changes I make might not be sort of carried through. Okay, so I think that's pretty good for setting things up. One thing we should do, you can see the little asterisks right here where it says my game and so on. And we've got this little asterisk. That means it hasn't been saved. So you kind of have to save in two spots. You have to save the code, which we'll get to, but you also have to save the game here. And sometimes students forget to do that. So it's a good idea, right? Once in a while, hit the save there. All these changes, so these folders we've made have been saved, right? And things will be better, right? If you make sure that you save there. Don't forget to do that. Now I'm going to give you some images here, and we're going to put them into our game. I'm trying something new here, so let me just see. I'm going to bring these guys in. So I have four. I'll bring in them all, I guess. I've got 4 images here. I'm just going to highlight them all and drag them into my sprites folder. Now you might have to get these from Teams or whatever the case is. And I'm just going to take a look at these. So these are looking pretty good here. Oh, good. Oh, good. Yep. Wonderful. So they all come in as PNGs, and PNGs have the benefit of not having a background. Well, you can have a transparent background, I should say. They don't always have a transparent background, but as you can see, they've just come in very nicely here. And I haven't brought in the sprite sheet. We'll talk about that sprite sheet sort of as an extension there, but I've given that one to you as well. Now, when they've come in, right, the background is transparent so that they can go on top of each other. Well, they will be able to go on top of each other and, be able to, they don't block each other. Okay, so if you're looking for more images, which you might be later on, usually PNGs are what you want because PNGs will let you have this transparent background. Okay, so those are, I'm just going to get rid of those because I just wanted to make sure everything was in there. I'll actually get rid of all of them except for the map. So let me just get rid of the Pokeball and get rid of Charizard. I hope I'm saying that right. My son will correct me if I'm not. And what we'll do is just get this map set up. Now, if I did look at it in the game, it's a little on the small side. You can do one of two things, and I think we'll do two things. We'll do it both here. So what I'm going to do is just scale this up a bit. And so on the scale here, I can change it. Now, of course, if I do it just once, that's on the X, stretches it that way, and that sort of distorts it. So making sure that I do it on both will be the best. And then also, on the Z, even though the Z here, we're in a 2D game, so we don't need X, so we don't need the Z, we don't need the depth. I'm going to just make sure that that's 2 as well. Now, the other thing that I'm looking at here is this position. And most of our game objects, the rule of thumb is center them. And so what I'm going to do here, especially if they're sort of important things like this background, I'm going to go in and just click on these 3 dots right on the edge there and just, well, I should have done that before. I'll do it again. Actually I could reset. There we go. Reset the position. Okay. If I hit reset, it will reset everything. And I've changed the size already. So if I go reset property, I can specifically choose the position. And there we go. So now what it is it's centered in our game world, right? So if I sort of zoom out, this kind of part here is 0, 0, and this is stretching out there. Now when I go to game again, yeah, it's not bad, okay? It's sort of, zoomed in on that. We can play around with this as well. We could change the scale, but we can also go to the camera. And what you'll notice is with the camera, you can sort of change the size there. So this size, either brings it in or moves it out. So again, depending on what you want to do, you can change that number. We'll sort of see. I'll make it a relatively close in, and then we can do that as well. One last thing I will say is that the background, we sort of saw that it was this blue color. Probably advisable if we get close to the edge to not have the blue. I notice there is a little bit of white there. So maybe what we'll do is just set that background to white. And then that way, if we do happen to, our camera does happen to sort of show the edge, we have a bit of white there, and then it sort of goes into white. So it's probably less jarring than having sort of a blue around it there. All right, so I think we're pretty good here. We will do a lot more. We don't have much of a game here yet. We'll do a lot more as we sort of continue on, but I think we've got a pretty good start here. So I'm going to save it one more time, and then we'll come back and actually start working on the player. In this part, we'll get our player working here. So I've got my Pokeball, and just like we did before, let's just drag that guy in. And, this is one issue. He is now hiding behind the map. And when you think about 2D games, there's really no depth. There's no sort of Z like I was talking about. That would sort of be in the depth there. But we can have sort of this order in the layer. And so the map, it makes sense to have that one at 0, since that's sort of our base. And so our Pokeball, let us change that to 1. And there you can see it pops up. And then I can, move that. Let's just reset the position. So I'm just going to do reset this time, and it's centered. The map, the center of the field isn't quite centered, but we'll deal with that later, but let's just have our ball centered there. Might be a little too big. Like if I go to the game window, yeah, he's probably a bit too big there. So maybe let's cut him down by half. The astute observers there might notice there is this one you can turn on, that if you do turn that on and you change one, they all change. It makes a little quicker there. Okay, so there is our ball. And you'll notice that this one, because it is a sprite, and I guess I should have showed you on the map as well, but it has a sprite renderer. So this component has been turned on. If I turn it off, right, if I click that button off, the sprite disappears. You can actually see there's a link to the image there, right? And it actually highlights it there. Okay, that's the one. I think you can go in and you can actually change the color if you want. There's a few things that you can do. But again, we'll sort of leave these for the moment. I guess you can flip it on the x-axis, right, and the y-axis and so on. But we'll sort of leave that at the moment. Now, what we don't have is any way to move it, right? It's just sort of static. It's sitting just like the map, and we want to be able to add it. Now, if something's moving around in your scene, we need to give it sort of physics properties. So that way you'll be able to accept force. We can sort of monitor its velocity, a bunch of different things. So at the moment, like I said, it's just like a map. It's just sort of sitting there. Anything that's going to move, we're going to have that sort of physics component. And the physics component, so I'm going to go under here, add component. Now you can see there's physics 2D. We'll just ignore physics for the moment, but go to physics 2D. And there's something called a rigid body 2D. Okay, so right there, rigid body 2D, we're going to add that. Now this, like I said, gives it some physics properties. So you'll notice there's mass, there's drag, there's gravity, there's something about collision here, and a few other things. So all of these deal with the physics. And so what we want to do is be able to access this physics and be able to push it, basically. That's how we're going to work this game. We're going to push this Pokeball around with our keyboard. And so we need to be able to sort of go in and program on that. Now, what's interesting is if you hit play here, show this, boom, there it goes. It fell. And in fact, if we go to the scene and I go way out, there it is. It's falling to the ground, okay? And so, or falling, there's no ground, it's just falling. And so what happened there is that we had the gravity scale set to 1, and that sort of is like 1 equivalent of Earth gravity. So if I go in and I plus 0 and I play again, what you'll notice now is the ball does not fall, so it's no longer falling gravity. Okay, so that's good. That's good. But we don't have anybody. Let's just see. If you get really far off, like I'm way zoomed out, easy way, just double click and it sort of focuses in on that game object there, okay? Yeah, but we don't have any way to move this. So there is physics on it. We can push it, but we need to be able to, use the keyboard to do that. So let's figure that out next. So what I'm going to do is go into the scripts. And I see that I was a bad boy and I put my scripts, I put my sprites in my scripts folder. No problem. I'm going to select those. So I'm going to hold Control, 1, 2, 3, 4, select 4 of them. And then I'm just going to drag them right into the sprites and empty my scripts folder. There. So now I've got all my sprites in the sprites folder. Imagine that. And no scripts in my scripts folder. So what I'll do here is actually go in and make a script. So in the scripts, make sure you're in the scripts folder and you can kind of see it right there. Right click, create. And you don't have much choice anymore. You used to have choice between JavaScript, Boo, and C#. We only have a C# script there. So we're going to choose C#. And it gives you this little sharp sign for music people here. And then it says new behavior script. That's the default name. Now, before you do anything, change the name of that script. So I'm going to call it player. That's a good name. It's going to be the player script. Press enter, and it's been saved there. Now, you might notice that over on the right side, sort of in this inspector, it kind of shows you the code. Okay, we're going to look at that in a minute. But the thing is, you click on it and you can't edit it. Okay, there is no way in Unity itself to edit the code. So you might recall that or the previous video, it feels like yesterday, in the previous video, right, we set up this external tool being the Visual Studio. that's what's going to do the code here. That's what's going to allow us to edit the code. So if I click on this, reload, I guess. Okay, just don't save. I think I did something there. Okay, we have our script here. Okay, so this is the default script. We don't necessarily need everything here, but for this one, I think we do. So we'll just sort of leave it. One thing I want you to notice is that player here, that the name that we gave our script, and this name here, the one that we sort of called our class, have to be identical. Sometimes students change it, and what ends up happening is if these two names don't match up, so the name of the class here and the name of the file, player.cs for C#, those don't match up, the script won't work. So just keep that in mind. What we're going to do is through code, we are going to basically move the ball around, okay? We're going to move that Pokeball around. So I'm going to do a couple things here. First is I'm going to come into the top curly brace. And so this might be a little bit different for some of you, especially if you've just done Python programming. We have these curly braces here. And these curly braces work the same way as the indentation of code. So basically everything that's in this player class, which you can sort of think of as a script, has to be enclosed in this outer curly braces. Then you'll notice here, these are functions. These are things that do something, and they've got curly braces around. So the start function starts there, and it ends there. The update function starts here and ends there. So these curly braces are very important in C#, and they, like I said, do the same job as when we had to press tab and indent. That's what was going on here. Now we're going to create one variable at the start. And we'll talk about what public means, okay? So they have variables in C#, just like in Python. We have to be a bit more specific here. So we have to say what type of variable it is. Now, when we did Python, we talked about ints, right? Integers, floats. We talked about maybe strings. So we didn't have to specify it. It just kind of figured it out based on the data we had in there. But in C#, we have to be sort of more specific and say, hey, this is going to be a rigid body 2D. So there's a rigid body 2D data type. And so in C#, and with Visual Code, it often gives you little assists here. So I'm going to choose that so I don't mess up the spelling. And notice it turns green. Now I'm going to give it a name. And usually I call it RB2D just to recognize it as the rigid body. Okay. Now that's sort of a variable there. It's kind of empty. It's just a variable that we've created. We haven't assigned anything to it. And so if I go into Unity, so make sure I save this. If you want to see your changes in Unity, you save it. You go back to Unity here. It will maybe take a second to re-import that. I'm going to go to the Pokeball, and we've got our sprite render. We've got our rigid body. This script is going to be a component. We're just going to simply drag it on and add it. And what you can see here is that this is our script player, and there's our RB2D, and it's saying none. It's waiting for this rigid body to go in here. Now, I think we could drag it in, but I'm going to show you a better way with code. So what we're going to do is go back to the code, and in the start function, and this function begins, like it says there, on the first frame, okay? So when you start your game, hit play, then this code will run, and it will only run one time. So what I'm going to do is it's going to look for the RB2D. So, and you can see it helps quite a bit here. But let me just sort of run through this. So what I'm doing is I'm setting the RB2D, which you saw was empty. I'm going to set it to a value. So there's our assignment operator. I'm going to say get component, and you can see it's sort of helping me out. So I'm going to grab the component, and the component that I'm going to grab is that rigid body 2D, okay? And there's a little bit of syntax here. We have to put in curly braces. This has nothing to do with HTML, but there's curly braces there. And so basically we're running this code that's going to grab the rigid body. I'm going to save this again. Go back to Unity. Give it a second there. And Now, I mean, it still says none here because I haven't run the script. But when I hit play, the script will run and it will find the Pokeballs Rigid Body 2D. Okay. So we've just sort of, through programming, been able to grab that. Now we're going to do a couple more things. Let us create 2 more variables. So I'm going to come up here and I'm going to call them floats. Okay, so, and we'll make them public as well. So let's do public float, and I'm going to call it move horizontal. If I can type. And same thing, and actually it gave it to me all there. Public float move vertical. So I've created 2 variables that are going to hold decimal values. And the values that it's going to hold are going to come from the keyboard. So what I'm going to come do next is skip down past the start, because that would only run at the very beginning. It wouldn't make sense to put keyboard commands in the start menu, because it would look for it right at the start and then never look for it again. So what we want to do is use the update, and the update is running however many frames per second your game is running. So if your game is running, 20, 50, 100 frames per second, it's going to run that fast. That also makes it a perfect spot to put in our code to check for the keyboard entry, because we have to always be looking, right? So someone might press the keyboard and the game has to respond. So that's usually why anything that has to do with user input will be located in the update function. So we're going to do 2 things here. We're going to, like I said, sort of populate or give value to these move horizontal and move vertical. And Unity already has sort of 2 things set up. So just make sure you're somewhere in between the opening and closing bracket in the void update function. And what we'll do here is we'll set move horizontal. We'll do that first. We'll set that to the get axis, and we'll talk about this in a second. Dot, just get axis. Sorry, my fault here. Input dot get axis. And when we get there, in the parentheses here, we have to put in a specific name, and we're going to put in horizontal. Like I said, I'll get to that in a second. We're going to do almost the same thing with the move vertical. So let's just see how much it helps here. Move vertical, okay, equals input dot get axis. No help here. And this one, it will be the vertical axis. And again, make sure you spell vertical right. Okay, so those 2 are basically the 2 variables, right? The 2 float variables that we created. We're assigning it a value, and the value is going to come from the input. So this is very common. You can have input, get key down, get mouse button. There's different types of input. And this one is specifically looking for this get axis, which when we go into Unity, I'll show you where that is. And then there's a special name for this axis, and it's called the horizontal. And there's another one called the vertical. Okay, now I'm going to save that code, and we'll go into Unity, and we'll take a look at what's going on. So down in this script here, once it fully compiles, taking its sweet time. There we go. We can now see that there's the move horizontal and the move vertical values here, and they're both set to 0. Now when I hit play here, so take a look at those 2 numbers, okay? So what I'm going to do is I'm going to make sure that I'm sort of in the play window here. Things are still not going to move, so don't be disappointed by that. However, if I press the right arrow, you can see there that the move horizontal went to +1. Let go of it, it kind of moves back to 0. If I press on the left key, okay, it goes to -1. So those arrows, +1 on the right and -1 on the left, those are going to be the values that basically those input keys are putting into Unity. And we're going to use those values to make our Pokeball move. Now, the other thing there, if you press up, it's a +1 on the vertical. And can you predict what would happen if I press down? Yes, you're right. It is a -1, right? So those 2 values there like the move horizontal and move vertical are the way that we're taking our computer or keyboard input in this case and going to be able to transform that into movement. Of course, you can hold both down. So at the moment, I'm pressing up and to the right to get two positive ones, and then down and to the left, we get the two negative ones. Okay, so you can move horizontally as well, or sorry, diagonally, I should say. I promised to tell you a little bit more about that get axis. And if you come under Edit and you come under Project Settings, there will be, let me see where you're here, Input. There we are, Input Manager. And you can see there's axes here. So there's input dot get axes, right? So there we are. And right at the top, you'll notice there's horizontal and vertical. There's also fire, jump, and a few other ones there as well. So let's just take a look at the horizontal one. We can drop the arrow down and we can see the name that's given to it. So that's why we have to be very specific about our spelling. We have to spell it exactly the same way as here, just like you learned in Python, right? That's important. It shows the negative button is the left key, positive button is the right key. So those are already preset. There is also an alternative. So if you're a WASD person, right, there is A and D, again, negative and positive, to sort of, I could use those keys as well. The gravity here, now you might think, oh, that's going to drop down or something. Well, this gravity, these three ones, that gravity, dead, and sensitivity, make it more than just on or off. So you can imagine a key, right? When you press a letter on your keyboard, it's either, it presses A or it doesn't press A. So what this does here, and you could kind of see it with those numbers that shifted, they weren't always just 0 and 1. There was a little bit of a value in between. And that's kind of to make it a bit like more like an analog rather than just purely on or off. There's a bit of gray in the middle that makes it act a bit more like a joystick. So that's all. They've just programmed it because we're using a keyboard, but we're maybe makes more sense in a game to have a little bit of I guess sort of wait or time delay or whatever you want to call it, just to sort of more emulate a regular joystick. So that's what those values are. And you could play around with them if you want. If you put your mouse over top of them, usually they give you a little bit of an explanation too. There we are. Just have to be patient, right? So the speed, for example, the gravity speed in seconds that the output value falls towards neutral when the device is at rest, right? So that's, if I hit play again here, when we look at this number, right? So we're in there. If I go to the right, when I let go, it doesn't go right to 0. There was a few numbers in between, and that's that fall off. So that's the gravity as it sort of, I guess, drops back to its neutral or middle position there. Good. Well, let's get this Pokeball actually moving because we've got the keyboard inputs in, but we don't have it moving. Thankfully, it does not take too much more. Sorry, where am I here? There we go. So like I said, we got this in the update here for the moving around. What we're going to have to do is apply those values to the rigid body. Remember how the rigid body has the physics in it. So I'm going to come down here and I'm going to create another variable, and this one, function, and this one I'm going to call fixed update. And what fixed update does is it really works with, there we go, it helped me out. It really helps with the physics. The physics does not get updated every frame. It basically is fixed to about 20 frames per second. And so if you want to do anything with the physics and accessing rigid body, it's best to put this into the fixed update. So what I'm going to do is create a movement. So it's going to be a vector 2. So that's the XY coordinates. And ignore what it's saying there. We're going to call this variable movement. And we're going to set it to a new vector 2. Okay, and I'll sort of explain this in a second once we get in here. And just like it suggests on mine, we're going to put, the opposite way though, move horizontal and then move vertical. So there we go. Okay, now what this is doing is it's creating basically an arrow, so that's what a vector is, that is pointing in a certain direction. And it's pointing in the direction given by the move horizontal and the move vertical. So recall that, the horizontal is going to be either pointing left or right. vertical is going to be pointing sort of up or down. And then so a combination of those two, you can imagine if those are sort of both 1, it would be pointing to the sort of diagonally to the, I guess, top right kind of thing. So that's what that's doing. It's sort of setting those two values together to indicate where it's going to push. And we could even call it direction. I mean, that's kind of what it is, but I've called it movement here. So what are we going to do? Well, we're going to take advantage of that value now to actually add a force. So RB2D dot, we can do add force, and it's actually giving it to us all there, movement. And so what this will do is basically push the ball, okay, or push the Pokeball in that direction. So force, if you remember from science class, is a push or a pull. So it's going to push that Pokeball forward in that direction. Now the amount of force it's going to give is going to be between 0 and 1. Well, I guess -1, but it's more direction. Really between 0 and 1 there. So let's take a look at this. We should actually have it moving. If all goes well. So I save that. One thing, I haven't made any errors here. If there are errors with your code, they might pop up down here. It says 0 errors, so wipe my brow and say good. Go back to Unity. Give it a second, and then I'm going to hit play here. And then I'm going to grab my arrow keys and start pushing. And so it moves to left, it moves down. There's a little bit of an issue. It moves off camera, but it's still there. I should be able to bring it back. There it is. You can see it has a little bit of weight to it. It doesn't want to stop. We can fix that a little bit as well if we want, but it just sort of moves around almost like an air hockey thing or something, right? Like it's an air hockey puck. We can sort of move it. It feels a bit like it's on ice. It's a little slow. We'll fix that up. But, you know, we could also get it to maybe slow down too. So when you look at here, there's one thing called linear drag, and I'll just bump it up here just to show you. It will make it harder to push it to begin with, but it will also kind of stop quicker, okay? Now, if you did want to have it stop quicker but move faster, we can increase the force. So we'll try fixing that here. I'm going to go back to my script. I'm going to put in a new variable here. I'll make it public as well. I'll make it a float as well. And it seems to have known from what I did before. I'm going to call it move speed. And so what this is, and I'm actually going to set a value here. Let's set it to 5, F. So we have to put an F there to indicate that it's a float value. 5 itself would be an integer, so 5F indicates it's 5 float. I'm going to come down, and what I'm going to do is I'm going to multiply this by the speed. And, whoops, sorry, move speed, I should say. Move speed, that's what I want. Move speed. And so what it's going to do is it's going to, instead of it being a 1 value at the most, it's going to be a 5 value, right? So we basically increased our force by 5 times. So I'm going to hit save. Come on back to our good old friend Unity here somewhere and just see. Now the nice thing too is I've got that value right here. So if it's too high or too low, I can sort of fix it here. So it's not bad. Okay, it's maybe a little slow for me, but I do like that increased linear drag, right? It makes it a little bit slower. Like it sort of slows it down quicker. So I'm going to pump that up to 10 and just sort of see here. Oh yeah, I think that's pretty good. Okay, it seems to move, it accelerates nicely, and then it does slow down. So yeah, I mean, there's no right or wrong answer here, right? You're the game designer, so you can kind of pick what you think feels the best there. One thing I'll note though, remember how I mentioned, I think on the first part of this video, that if you make a change while you're in this play mode, in this red mode, what you'll notice is that number will actually go back to 5. So if you want to keep that, right, you got to put it in again. So I think there is some way to bring it back, but it's just, usually I just do it that way, right? I just sort of put it in as I need to. So maybe a good idea here is to save it up. And yeah, what we've got to look at next is, yeah, we can kind of go outside the camera. That's one thing. So we should put something on the camera. And then we're going to probably have a little bit of a problem when we go outside the play area here. So we'll take a look at that as well. Now that we've got the player moving, let's try to get this camera to follow a little bit so the ball doesn't go off screen. So this is going to be a very simple camera controller that will simply sort of, just shadow the movement of the player. So where the player goes, the camera goes. Nothing fancy. So to do that, we'll use another script. So generally the scripts are pretty specific, pretty short. They just do what they say they do. So in this one, it's just working with the player. We're going to cheat a little bit and put the score on the player and a few other things. But generally, you want to keep your scripts pretty limited to what they're doing, sort of thing, one thing. So I'm going to right click here, just like we did before, and create, and we'll create a C# script. This one, again, before you'd let it, sort of become new behavior script, change the name. So I'm going to call this camera controller. And I'm going to double click on it. And we're going to see that open up in Visual Studio. And so again, we've got their camera controller, that's good. We're going to create two variables. One is going to be, well, we'll make it public. We'll make them both public just so we can see it here. Game object. So it's the type game object, and it's going to be the player. So we're going to look for the player here because the camera needs to know who the player is. So we need to create a reference to the player. The one thing to think about is that because this script is completely separate from Unity, we're kind of just putting in placeholders here. It doesn't, like, Visual Studio and the C# script doesn't know who the player is. So once we go into Unity, we have to sort of direct it to it, and I'll show you that. The other one, well, we could make this private, but we'll make it public. Vector3, and then this will be, we'll call it the offset. And you'll see how that gets used in a second. But remember, vector3 would be the X, Y, and Z coordinates. So we're including Z here because the camera is really in 3D. Even though we're making a 2D game, if you pull back the curtains, as so they say, there is this little 2D button here. And so what you'll notice is when I do that, this is all in 3D space. So yeah, Unity is really a 3D game engine, and we're simply, avoiding certain things just to make it a 2D game. So just keep that in mind. We're really in 3D here. So vector3 offset, that looks good. What we'll do is right at the start, we're going to measure the distance basically from the player to the camera. And so how do you measure distance, or sorry, difference, right? And what we're going to do is just figure that out. So what it's going to be is the transform dot position, I guess I could press tab there, of the camera minus the player dot transform dot position. So what this is going to sort of measure the distance between the camera, and this notice it just says transform dot position. Sometimes people like to do this here, and that means this object. So this game object, so this game object is going to be on the camera, so therefore the camera's position. And remember, transform dot position, what that is the transform's position, okay? That dot between them, I always think of that as like possessive, like comma S, right? This is camera or transforms position, right? So this object's, I guess you could say it better, right? And this object's transform, and that transforms position, okay? So we're taking the camera's position and we're subtracting, so we're finding the difference between that and the player's position, basically. Okay, so when you measure that, that's actually going to give us a distance in the X, Y, and Z coordinates. Now, we'll come back to that in a second. Technically, don't worry too much about this, but we should put this in the late update. Again, don't worry too much here. It's a little bit of detail, but in the update, we can have things in the same cycle happening at different times. And if you don't want it to sort of overlap or to occur too early, you can put it into this late update. So again, small thing here, but don't worry too much about it. So what we're going to do is this is, maybe I'll put this in front of this as well. This dot transform dot position. Okay, so what we're doing is we're going to set, I should say, we're going to assign, right, the camera's position, because this is on the camera, again, this refers to the camera. We're going to assign its position to be whatever the player's current position is, dot sort position, transform dot position, plus that offset. So what's going to happen is the player moves, we're going to say, oh, the player's moved here. We're going to move the camera to that position, but always the same distance away. All right. So that's what that offset is there. If we just said transform.position equals player.transform position, the camera would be sort of like sitting right on top of the object. You might want that, but we want to maintain this sort of offset. So let's take a look at this. And this is the whole script. Pretty straightforward here. So I'm going to come in and press the save button and then go back to Unity. And now it won't work, right? Because this script is only here. So what I have to do is make sure I'm on the camera, drag that script into here. Now, before we can do anything, you can see the player, it says none, right? And so if I do hit play, this is a very common error. We'll get down here. We get in the console, and it keeps doing it over and over again because it's looking for this. It says an unassigned reference exception. The variable player of camera controller has not been assigned. Okay, and that gives you a suggestion. You probably need to assign. So what it's saying there is that this is empty. So all we have to do is, the Pokeball is our player, drag it in, and there it is. Okay. Below that is the offset, so it's measuring the offset. Now this isn't going to be too exciting because the camera, and you can kind of see it here, right? There's the camera, well, it's disappeared there. The camera icon and the Pokeball, they're on the same location. Let's just say, just for fun here, I'm going to move my Pokeball down. So I grab an arrow there and just, whoop, I'm going to put it in the center. So my camera and the ball are not quite perfectly aligned, right? The camera's position is 0, 0, minus 10 on the Z. So remember that. And the Pokeball is at 0, minus 1.45 on the Y. So when I hit play now, and we'll go back to the camera, what you'll notice here is that it measured that difference, right? So there's 0 because the X was the same. It's sort of centered horizontally. The Y, we kind of pulled this down, so the difference is 1.45. And then that Z, the camera's sort of further away, so it's minus 10. Now, the real good thing about this now is that we can go off and visit. I didn't really realize. I said, oh, this is a washroom here. We can go visit the washroom. We can go to the shed. I guess that's what that is, some sort of dugout or something, and then sort of move ourselves around, right? So now we can sort of move around the field. We can say hello to the, thank you for making these maps for us, and sort of move our character around. Okay, so that's pretty good there. We've got a camera going, we've got our movement going, and I think next that we should do is trying to prevent us from going flying out of here. So I think we'll create sort of like some boundaries on the edges of the map, and maybe some boundaries around these objects here, but then sort of allow us to go anywhere in the game. Okay, so we'll do that next. Let's just turn that off. Let's make sure we save as well here. So with the colliders, what we will do is, there's a couple things we could do, a couple of ways we could do it. But like I said, we'll just set up some colliders that sort of go around these edges, around some of these buildings. Excuse me. And then ones around the edges as well. You can choose if you want to do the trees or not, up to you. So what I'm going to do is create an empty. So an empty game object, there it is got nothing in it except a transform. All game objects have basically a position, but they don't necessarily, they have sort of like a transform, but this one doesn't have any components here. So what I'm going to put here is just call it, I guess, the colliders, something like that, the fences, whatever. And we're just going to add a bunch of components here. And so if you go down, what I'm going to look for is a box collider 2D. It is in the physics 2D section, and I'm going to put that in. Now, right here, you can see a little box, and you can actually sort of go in and edit the collider. Usually, it gives you little hints there to hold Alt after clicking, handle to pin the center in place, hold Shift after clicking to scale uniformly. So there's a few little things you can do there. You can also just drag the edges. And so maybe what I'll do first, I'm going to do this guy. There it is. So there's our first little box around there. So we have a collider around this. Now, I'm pretty happy with that one. Well, yeah, I think what I'll do is I'll just, I can copy that component. And if I click on there, I can paste component as new. So there it is. And this time I'll just, the offset, I'm going to move it to the left there because it should be the same size, or if it's not, I can pretty well. But there we go. So those two are done. This one, I mean, I could copy or just make a new one. I think I'll just make another one. Box collider, sort of drag it over. It's going to be roughly there, there. Probably the easiest way. Good. So now we've got those three, sort of the buildings kind of done. And then I'll just sort of box colliders around the edges. So probably just add a new one again. Box collider 2D. Just stretch it vertically, stretch it horizontally, and I might just go a little bit out and a little bit like that there. Now, I don't know if there's going to be enough room to get between it, but whatever, that's okay. Do something like that. And then, like I said, that would be a good one to duplicate as well. So I'm going to copy component and then paste that one as well. Paste component is new. So I've got that one. That should be the very bottom one. And again, the offset on the x-axis, move it over to the left. Okay, there we go. And we're almost done. Just two more. So I'm going to add component. Let's just do another one because this one's kind of different. So I'm going to stretch it horizontally this time. And I guess it doesn't have to go all the way over there. There. And then I would lift that up. And there. Now I might have to fine tune these a bit. I've been pretty careful, but I think that's going to be good. And then I probably just copy that one. So again, we're doing a lot of the same stuff here. Copy component and then paste as new. And again, the offset this time, I'm going to mess with the Y and whoops, bring it down. I think I went too low. Just to the edge there. There we go. So that's pretty good. Like if I wanted to do that tree, just to give you an example, it's, well, yeah, you could use a circle collider and you can do that later. I'll show you how to put a circle collider on the Pokeball. Now, when we hit play here, I put colliders in, but and the camera will follow, but you might be disappointed to see that, it still goes through. So, what's going on here, right? Well, the problem is that to have a collision, both objects need to have a collider on it. So at the moment, our Pokeball does not. So it just sort of floats through. So pretty easy to fix that, though. Just go to our Pokeball, come down to the bottom, add our component. We'll look for a circle collider. There it is. And whoa, a little bit too big. I don't know. Usually it's pretty close. I don't know why it's so off. But the center... Sorry, there. The center is in the right spot. So for the edit, it's a bit of a pain to edit that way. I just like to grab the radius because that's all we're doing and drag it down. You can see that green line. And so I would just get it. Again, you're not going to be too worried about, is it just over? Is it just under? So whatever, I would put it close to the edge as you can get it there. Okay. So let's just double check that this works. And so it should hit that, shouldn't be able to go there. That looks pretty good. Okay, so I don't know, we just want to double check it's not going out anywhere. Now you notice it is spinning, and you could stop that. I'll show that. This will be sort of an option for you if you want to do this or not, but it does spin around. So yeah, I mean, I don't think that's a necessarily bad thing, but maybe some Pokemon professionals will sort of say, that shouldn't be spinning around. It should always be the one way. if that's the case, there are some constraints here. So if you go back, we're in the Pokeball, and you come under the rigid body 2D, there are constraints. And under those constraints there's freeze position, XY, which we wouldn't want to do, or else our ball really wouldn't move, but we could freeze the rotation. So the difference here is that it's just going to, if it hits the edge, it's not going to roll, right? So the Pokeball is always going to be basically the same orientation. All right, so we're pretty good here. Now the next thing, and maybe we'll bring him in, we have not brought in our Charizard. I'm trying to sound like I know what I'm talking about here, but there he is, Charizard, right? So we're going to bring him in. Yeah, we're in the scene here. Now you might say, oh, he's disappeared. Where is he, right? Don't forget, he's in that same order in the layer there. So we got to bring him up. I don't know how big a Charizard is in relation to the ball, but to make the game a little bit more interesting, I am going to make him smaller. He's a maybe mini Charizard. Maybe that's a little bit too small. Ooh, not 5, 0.5. There. We'll go with that. We'll go with that there. Okay, so there is our Charizard, and he's got the name already on there, so we probably are pretty good in terms of that. Now, what we're going to do is we're going to take our Pokeball and we are going to make him disappear. We're going to put him in the Pokeball. I think that's how it works. I have to ask my son. He's my consultant on this game here. I just do the programming. So if I want him to disappear, well, what I got to do is, first of all, he needs a collider. And then I got to have the ball recognize that he's colliding with him and make him disappear. So let's do that first. Let's put the collider on him. Now he's kind of box shaped, so I'm going to go box collider 2D. And what I might do, it's got the wings. There's a bit of empty space there. I'm just going to shrink it down a little bit, okay? Just so it doesn't seem like you're too far away. Maybe something like that. Go a bit more to the, I guess, the core kind of thing, right? Doesn't really matter. Now, if we do this like we've got here, I'm just going to bounce into him, okay? Now, there is one little thing here that we're going to do, and this is a thing called a trigger. And what a trigger does is it causes an event to occur. So whether the collider behaves as a trigger or not, I mean, a trigger is almost like a sensor. So when something comes into his space, right, it goes into its collider, it's going to sort of send a signal in Unity. And so I'm going to turn that on. So the difference that we can see in the gameplay is that now that I go over it, it goes through him. Okay, now we're going to fix that up, so don't worry that it's in behind him. That's fine. But the key thing is now there's a collision, but it doesn't bounce off. And so when we do the is trigger, like I said, it sort of sends that signal. So we're going to take advantage of that. So I'm going to come down in here, and I'm going to go back to the player script. So we're back in the player script. We're away from the camera in the player. We're going to create a new function. And this function already exists in Unity. It's sort of a built-in one. It's called onTriggerEnter 2D. And what it does is if you run into a collider, whatever we've run into, it will grab that, whatever it's collided into, and call it collision. So then what we can do basically is just, I would say it, I guess, send a little signal that we can pick it up. Now, let me just see here. So I'm gonna make it very simple first, and then we'll make it a little bit more interesting. So collision, it's all here. I think that's because I've done it before. So I'll explain this in a second. So collision.gameObject.setActive to false. And what is going on here? Okay. So like I said, this object, whatever you run into, so you're the player, if the collision, so if this thing is a game object, we can set its active to false, Well, what does that mean? Well, let's take a look here. Go back to Unity. There it is. Okay, so what's going to happen is that when we go in, I want you to watch this little box up here. So once we move our little Pokeball close to him, he disappears. And notice this has turned off. Okay, this on is true. And it keeps bumping back and forth because I'm on top of it. So that is true, meaning the set active is set to true. So it is active. And you can see here he's sort of active in the scene. And when I turn that off, right, the set active has been set to false or not true anymore, right? So that's what's going on in the code. We're basically grabbing that little box and we're changing it from a check mark, which was true, to a no check mark, which indicates false. Now, I think, yeah, so what we're going to do next is kind of just make it more precise, I guess we'll say. Okay, so we'll take a look at that so that we can differentiate between what we're picking up. So I'm going to just make sure I save it here. Must exit play mode to save, yes. Even though I had a bright red there. There we go. Okay, you ready?
Okay.
So Ryan, what do you think about this game so far?
Bad.
Hey, come on.
Bad? Well, come on, play.
Okay.
Aren't you going to play it?
There.
Oh, you got Charizard! You can explore the world here, too.
It's just such a small map.
Small map? Oh, you go and pick a bigger map then. Don't go to the washrooms.
What is this?
Yeah?
Can I play Guess the Song?
Guess the song. I don't know any songs. Unless they're from the 1920s or something, because that's when I was born.
Okay.
So what do you think, Ryan? What is the score of 1 to 10? What would you give this game?
2.
A 2. Elisa, what would you think you'd give this game?
Needs to be completed.
It needs to be completed. Oh, so it's sort of like...
So this is an incomplete project.
It's an incomplete project. Oh, my kids are pretty harsh critics here. So, okay, we've got more work to do then.
What? Wait, you were...
So the one thing we might want to do is differentiate between, say, this pickup and other pickups and so on. So the easiest way to do that is to use a tag. And so what I'm going to do is click on our Charizard here. And you can see up here, just under the name of it, there is a tag. And that tag says untagged. And so if we go down here, you can see there's a bunch of pre-made tags, and you could add a tag as well. Now, you might have to vary this for your game. I'm just going to simply call this a Pokemon. Okay, so if it's a Pokemon, then we want to be able to pick it up. Now, one thing you have to be careful, we've created a new tag, but I have to go back to Charizard and then be able to select it there. So there's the Pokemon one there. Now, when I go back into this code here, this will still pick up, right? We set this trigger. We set this tag that we can use for this trigger. What we can do is we can put a conditional in here. So if, and then we can say that if the collision dot game object, there we go, dot compare tag, and the idea is this is going to check the tag, and if that tag is Pokemon, then what should happen is I just need to put collision. We'll put curly braces around this. It will set that object to false. Now, what I'll do is just show you the difference here. So we've got this, like I said, the object that we're colliding with, just like we did here, we set that one to false. But now we're just sort of doing a check at the start to make sure its tag is Pokemon. And let's take a look. Make sure I save that. Go back to Unity. There we go. And what I'll do is I'll create another Charizard just for the moment here. So I'll just duplicate this. If I right click on it, you can duplicate, and I'll just move this one over here. This one I will untag, okay? So just to show the specificity here, when I move over, so to the first one, okay, this is the untagged, nothing happens, okay? So this is because it's untagged, it doesn't pick it up. However, when I come up to here, it's gone, okay? So you could tag your different Pokemon, in different ways. But the idea is that now it can identify. It doesn't just do it for any object that it runs into. It only picks up the ones that are tagged, in this case, Pokemon. Now, I'm going to get rid of that guy there. The other thing we can do is if we want to make more Charizards, right, if we had to have them in our game there, we can go ahead and create we've already got our folder here with prefabs. If I take my Charizard from our hierarchy here and just drag it in, what ends up happening is that he becomes a prefab. And so if I want to go into that prefab and place a bunch around my game, that's sort of the easiest way to do it. So if I was trying to put these Pokemon in different locations, I could simply do that. One thing about that is that, for example, they're just too big. I want to make them smaller. Well, instead of going around and changing every individual one, I can click on my prefab. I can come in here. Let's say I'm going to make it a quarter the size. Press tab, I guess. And now all of them that are prefabs are going to be the same. They're basically like almost identical, right? They're identical ones. They come from the same, the same plan, and then we just put them out there. I could go and change one individually. So say I want to have a Super Charizard or something like that. Now it only affects the one because I just selected him here. It doesn't affect the original prefab. I can, a little bit technical here, but I can go and do the overrides. You can see here that I changed something into transform, and I could apply to all, and now my prefab now has that scale of 1. So just pop that back to 0.5, and then all of them go back to 0.5 there. All right, so those are kind of some of the ideas with sort of the pickup and prefab. I'm going to add one more script to this Charizard. He's not too exciting, and I'm just going to get him to spin, so just to attract our attention here. So I'm going to create another script, create C# script, and I'll just call this the rotator. This is going to be a very, very simple script, so just make sure we named it first. Open it up. Rotator, good. All it's going to do is in the update, it's just going to spin around. So I'm just going to transform just play with the transform. So transform dot rotate, and then you can see here it brings up 3 different values. I'm going to change this a little bit. I'm going to do in here, new vector 3, that's what I want, new vector 3, and we're going to put in 3 values here. And so it's going to be 0 on the X, 0 on the Y, and on the F, we're going to, on the F, 0 on the Y, on the Z, we're going to spin that. And so we're going to spin it 45 degrees. It's a very good idea just to make sure that these are all floats. Do that. Now the Z is the one pointing into the screen, and so it's going to rotate around. And I'm just going to make sure I multiply this by time.delta time. And that's just sort of the real time that's going on in the game. If you don't do that, it could spin really quickly on some computers and slower on other computers. So if you multiply it by time.delta time, it just makes it consistent across all computers. And that's all we have to do. So it's just going to simply rotate this object through the z-axis, and we can see that when we put it on here. So what I'm going to do is go back to Unity. Since I made it, this is going to apply to the prefab. I'm going to go to the prefab here, and I should be able to add that component to the prefab. So my scripts, rotator. That way all of them should have it. And they're all tagged Pokemon. I just wanted to double check that. And when I turn this on now, there they are. They're rotating, and I should be able to pick them up. And it works perfectly. Good. So I'm collecting my Pokemon. Right. I think the next thing that would be a good idea is to create a score. So we'll do that next. So we'll place the score on the player. So let's go into player and just get the score working for the moment. So we'll go to the player script. And what we'll do is come up to the top and just set a value for the score here. So public int, it will be an integer, it doesn't have to have decimals here, and we'll just call it score. Now, at the start of the game, what should we do here? Well, let's set the score to be 0. So that makes sense. And then the question is, well, when do we need to increase the score? Well, we can increase the score when we pick up a Pokemon. So we'll come down to the on trigger enter 2D, press enter there, and there's 2 ways we could do this. So I'm going to do both ways just to show you. So we could do kind of what we did in Python. We can't do the plus equals though. We could do equals score plus 1. We could do it that way. Or we could also go score, and in C# you can go plus plus. And that's called the increment. So both of these are the same. Just choose one style, but they both do the same thing. So I'm just gonna, whoops, I always forget that's my Python showing there. There we go. Just comment that out because we don't want to score it twice. This is probably the most succinct here, right? The easiest, the increment, score plus plus. That will just increase the score by 1. Now I think I made it public. Just let me double check. I did. So we can actually see this working. Come back to here. And just make sure I click on my Pokeball. And what I'm looking for here is on my script. There is the score. It is 0. And I should watch it increase as we pick up our character, or pick up our Pokemon. So there's 1, 2, 3, and 4. So it all works out fine. That's good. But the problem is, if we were actually playing this game, we don't want to be looking off onto the side here, right? When you build the game, this isn't going to be visible. So that's kind of, I don't want to say pointless, right? But for the player, they're never going to be able to see the score. So what we need to do is create a UI, create a user interface that will show that score. Now it's a little bit tricky here, but we'll take a look. So I'm going to go under Game Object, and you'll notice there's a section called UI, and there is a section called Text. And so what we're going to do is we're going to put some text in here. And it's a little bit different than previous years. There's the old legacy text, but we'll go with the new Text Mesh Pro. Gives you more flexibility with how that text looks. Click on there. You have to import the TMP essentials. So give that a second there. You don't have to bring in the examples and extras. You could play around with that if you want later on, but that's not the point here. Now the canvas, I'm going to zoom way out here. The canvas, there's the new text, way out, is kind of like an interface between the camera and the game. And it's even though it's, the scene is way down in there, this canvas is sort of what we are going to view when we play the game. So you can see how this new text is just kind of sitting off to the left here. If I go game, you'll see it's kind of sitting off to the left of our screen. So like I said, it's between the camera and the scene view. Now what I'm going to do, whoops, we need to do that. What I'm going to do is set the position. Now you might be tempted to sort of grab it and move it over and say, oh, I want it sort of centered here or off to the left or whatever the case is. Not the best idea. What you should do is come up to this location here. Okay, so in the text, and we should maybe call this score text. There we go. Better name for it, descriptive name. We want to locate it with this. So if I click on this little guy, you can see you can set the anchor. Now I'm going to put it on the top left. Okay, so that's where I want it closest to. So what I'm going to do is hold the shift down and the alt and click that top left, and you can see it pushes it into that top corner. The reason this is important is that when you play this game on different screen sizes, if you go by just the pixels, you've maybe centered it and then moved it way off from the center, like over here. Well, if it's a small screen, yeah, maybe 500 pixels is good, but if it's a big screen, it might be, you might want it 1,000 pixels over. So you just need to make sure that you put it as close to the location you desire with your anchor, and then just move it from there. So what I'm going to do, to sort of zoom in, it's really close to there, so I'm just going to move it a little bit off the right, so maybe 10 units over, or off the left, move it to the right, and then maybe a little bit down. So maybe I'll do it 10 down, and I think, yeah, I got to go -10 on that, just to bring it down. And there it is there. Now, this here, this text, is what we're going to sort of manipulate. I'm going to put here score, colon, 0. And then we could change the size if we want. So what I would do is just look to see, is that a good, I'd say that's a pretty good size there. Okay, but you can change it up if you want. You can also change the color of the text. So if you wanted it red, you know, there's probably bold there as well. So you can play around and see. Now this is sort of the static placeholder text. We actually have to go into our code and manipulate it. We have to get it to update. So what I'm going to do is go back to our code here, and I'm going to create something called the score text. So I'm going to make this public as well, and hopefully I get this right. TMP text underscore text. There it is. Okay, this will be a reference. This is the type of text, and then I'm going to call it score text. Now what we can do is we can manipulate this text. Now I'm going to do it the bad way first, and then we'll make it better in a second here. I'm going to come down, and so the idea is that when we score, we need to update that score text. So what I'm going to do is go score text text. So this is going to manipulate the text, and I'm going to set it to, I'm going to put it in quotes here because it's the score, colon, space. That's a string, like we know before. And I'm going to concatenate or add on the score, but it's a good idea to make sure it's a string. So there's a toString. So you remember in Python how we converted from text to integer, or we convert from integer to text. That's kind of what's going on here. We're setting this score to be a string. Now this will work to an extent. Let's hit play here. Back, save it. And when we hit play, so the score is 0, which is fine. It didn't go up. Now I'm getting that null reference exception. So what did I forget? Well, I created a reference to it on the Pokeball, right? TMP text, but it doesn't know what the text is. So make sure I drag that over, hit play again. That should get rid of this null reference exception. And now hopefully the score increases. So it is, okay? And everything looks good. Now one thing that's not good is that at the start, you know, I was sort of relying on this to be exactly score 0. If I had, say, I don't know, just put as SC here, for example. If I hit play, you can see the score stays that way, and it will stay that way until I play or hit 1 there. So what I'm going to do is just update the text here. So I'm going to create my own function. Let's just get this. I guess it will fix itself there. I'll just press enter a couple times. So I'm going to go private void, and I'm going to call it score text update. Update. There we go. And I'm just going to, that's going to be my function that I'm going to call whenever I need to update the score. So I'm going to take this, Control X, put it in there. And now what I can do is I can make sure I update the score. So score text update whenever I need to. And I'm going to do that also at the top. Score text update. So that way I don't have to rewrite that line of code. Okay, I've got a little function that will update the text, and I can do that sort of in 2 locations, once at the start of the game, and also every time I score. Okay? So it's just a simple way of sort of putting this line of code into something that's a little bit easier to use. So I'm going to save that up again, and just see here now. And so when now it says SC, but when I start that, it will run that score update, right? There it is. And then of course it will just work the same as before, where we update our score as our game begins, or as our game plays, right? As we go through those characters. Now the last thing that we're going to really do here for our game is just give them a message once they score, right? They get their score, that they win. So I'll show you how to do that. So to add this like uwin, give them a response here. What we want to do is go to game object, UI, and we're going to add another text mesh pro. And so this one's in the middle, and we'll just make sure it's right in the middle. So it already is anchored there. What's a good idea to get it really centered is, let me just find this here, is be able to, they've changed this on me, of course. The center, there we are. We can just sort of center the text and center it. Yeah, that should be good there. So that's really centered. Again, you can play with the numbers and so on. So the idea here is that we want this to say UN, something like that. Okay. Now to do that there, let's actually just change this here. Let's just change this to win text. And when we've got that, we need to go back to our script and create a little reference to it. So what we're going to do, come back up here, just like we had with the score text, we are going to make another public TMP text, and this one, let's call it win text. Now, what I'm going to do is when we win, we are going to pop that up on the screen. So what I'll do down here is once we score, we can check to see what the score is. So I'm going to come down a little bit below this one, and we can do another if. So we're actually going to have a nested if in here, because every time we score, we want to check if the score is greater than, and maybe greater than or equal to, I guess. Now this time I'm going to go 4. Okay, we'll improve that in a second. And then what we'll do is we'll do to the, I think, win text dot text. We're going to put in our little win screen, or win text here, right? So what should we say? Well, I just do what I did before. You win. There we go. We don't have to do a to-string here because this is already just a string. It should be pretty good there. So basically every time it scores, right, we get a point, we need to make sure that we're not at the top score here. Right, so I'm going to hit save, go back to Unity. Then one thing I want to make sure I do before I play is I've got now a spot for the win text. I need to drag that win text into here. And when I hit play, there we go. Now it says you win right away. That's not good. And it looks like it's got, that says I'm winning all the time. Well, it's not actually a problem with my code that I put in. It's something I forgot. And what I should do, the bad way of doing it, I'll show you the bad way, is I could just get rid of this here, because this is kind of the placeholder text. And so if I did that, right, it should work. Sure enough, there it is. Now, but yeah, I got rid of this here. Programmatically, I can get rid of this. This should, when I'm sort of working on the game, I might want to know what this looks like. So I'm going to leave this on here. What I'm going to do is I'm going to go back into the start. So up here at the start, just where I put the score text update, kind of the same idea. I haven't made a new function for this, but I'm going to do win text is going to be set to, I'm just going to make it an empty string. So there's nothing there. I think that should be good. Oh, sorry, win text, dot text. There we go. Right, it's an empty string. So I'm going to save that, go back to Unity. And when I do this, it now should disappear. So I hit play, just like it did the score updates, the win text disappears, and then I win, and the game is over. Now obviously this is a pretty simple game. There's not really a challenge to it. So we'll talk about all the different things that you could possibly do to improve the game. But one thing we'll do right at the end here is we'll build it so that we can actually play it on our computer. Now, we can build it for a web as well, but I'll just show the simple way here to build it for the PC. So I'm going to save here. I'm going to come on, so I would always save it before I build it just in case. I'm going to go to File. I'm going to come down to Build Settings. And you can see here we can build it for a variety of different platforms. Some aren't available to us. but we've got the Windows and we've got the WebGL. Now we're going to keep it on Windows here. I'm going to go to Build and Run. Doesn't really matter which one you do. Build. Come under here. It's going to ask me to save it somewhere. So I'm going to make sure that I put a new folder, and I'm going to usually call it my build folder. I'm going to click on that, select the folder, and it's going to build. Now, depending on the complexity of your game, this might take a minute or two. Don't worry if it all goes blank like that, and we're back. And you can see now it's opened it up, and here's my most amazing game. So I can sort of play around, right? Everything should work. It's a PC build here, and then I should, my score is updating good. And then finally, yay, you win. And that's a basic game here, right? I think I have to escape out of this. How do I get out of this one? There we go. Okay, so that is Unity in a nutshell. That's sort of the most basic game pretty well we could create. A nice little 2D game here. And yeah, feel free to modify it. We'll talk about how we can modify it in class. But that's your game.